need to add validation to an existing tool while keeping the original function completely untouched. We'll wrap a basic addition function with a validation layer that enforces positive inputs, showing how transform FN intercepts calls before they reach the core logic. You'll see two key patterns: using forward, when argument names match exactly, and handling renamed parameters with transform args and ArgTransform. The example also demonstrates why transform functions must always be async, even for synchronous validation, because they integrate with FastMCP's async execution pipeline. Plus, we'll cover when to use forward draw for direct access to original parameters, and how Quargs enables partial validation without listing every argument. From FastMCP, import FastMCP. From FastMCP tools, import tool. From FastMCP tools tool transform, import forward. MCP equals FastMCP. At MCP, tool. Def add x, int y, int. Adds two numbers. Return x plus y. Async def ensure positive x, int y, int. If x lesser equals 0, or y lesser equals 0, raise value error, x and y must be positive. Return await forward, x equals x, y equals y. New tool equals tool from tool. Add. Transform FN equals ensure positive. MCP, add tool, new tool. This demonstrates FastMCP's tool transformation pattern, where you create enhanced versions of existing tools by wrapping them with validation, argument modification, or behavior changes. The pattern uses a transform function that intercepts calls, applies custom logic, then delegates to the original tool using either forward for automatic argument mapping or forward draw for direct parameter passing. The key distinction is that transformations create new tool instances while preserving the original implementation, enabling progressive enhancement without code duplication. The pattern works through a two-phase process: schema transformation and execution interception. During registration, tool from tool applies any argument renaming or hiding via transform args with ArgTransform objects. Then at runtime, the async transform FN receives parameters after all renaming has occurred. The transform function can validate inputs, modify values, or completely replace behavior while using forward to maintain proper argument mapping between renamed parameters and original function signatures. For cases requiring direct access to original parameter names, forward draw bypasses all transformation logic. All transform functions must be async to integrate with FastMCP's execution pipeline, even when containing only synchronous validation code. This approach solves critical problems in tool composition by enabling input validation, argument renaming for better LLM comprehension, and behavior modification without altering original implementations. You'd use this pattern when adapting third-party tools, adding validation to existing functions, or creating domain-specific variants of generic utilities. The pattern scales from simple validation wrappers to complete behavior replacement, with the official documentation showing common use cases like exposing client methods as tools, hiding internal parameters, and creating context-aware tool factories. For server-wide transformations, the same capabilities extend to MCP config for declarative tool modifications. Let's break it down. From FastMCP, import FastMCP. From FastMCP tools, import tool. From FastMCP tools tool transform, import forward. These imports establish the foundation for FastMCP's tool transformation system. FastMCP manages the tool registry. Tool enables wrapping original functions with validation layers, and forward preserves exact parameter mapping when argument names match between wrapper and original. The pattern supports both simple cases with identical parameter names and complex scenarios requiring transform args with ArgTransform for renaming or hiding parameters. For cases needing raw argument forwarding without mapping, forward draw provides an alternative, though this example uses the standard forward since parameter names align. All transform functions must be async to integrate with FastMCP's pipeline, regardless of whether the validation logic itself is synchronous.
MCP equals FastMCP.
This creates a validation wrapper around the original add tool using FastMCP's transformation pipeline. The ensurePositive function intercepts calls before they reach add, enforcing preconditions, while forward preserves exact parameter mapping to the underlying function. In production, you'd often use transform args with ArgTransform for parameter renaming like XA or hiding sensitive parameters. For raw pass-through without mapping, forward draw bypasses argument processing entirely. All transform functions must be async even for sync validation because they execute within FastMCP's async pipeline. The pattern cleanly separates validation logic wrapper from business logic original tool, with transformations applied server-side via MCP config when needed. The wrapper receives arguments after any ArgTransform renaming, so use quargs for partial validation where not all parameters require checking.
At MCP, tool. Def add x, int y, int. Adds two numbers. Return x plus y.
The @MCP tool decorator exposes this function to FastMCP's AI pipeline, using its type hints and docstring to define the tool schema. This establishes the core business logic that will be enhanced with validation or transformation layers. In this basic case, parameter names match between the tool and its transform function, but FastMCP supports renaming via transform args with ArgTransform when needed. All transform functions must be async to integrate with FastMCP's pipeline, even if they contain only synchronous validation logic.
Async def ensurePositive x, int y, int. If x lesser equals 0 or y lesser equals 0. Raise value error, x and y must be positive. Return await forward, x equals x, y equals y.
This transform function creates a validation layer that wraps the original tool, enforcing preconditions before delegation. While this example uses identical parameter names, real implementations often require transform args with ArgTransform to rename or hide parameters, like mapping x to a or omitting sensitive values. The forward function preserves exact parameter mapping to the original tool, but you'd use forward draw when you need to bypass FastMCP's argument processing entirely, such as for raw payload forwarding. All transform functions must be async, even for synchronous checks, because they execute within FastMCP's async pipeline. The wrapper completely replaces the original tool registration via MCP add tool, making validation mandatory while keeping the core logic unchanged. For partial validation, use quargs to inspect only required parameters, as the transform receives arguments after any ArgTransform renaming.
New tool equals tool from tool. Add.
This creates a wrapped tool using tool from tool, where ensurePositive acts as validation middleware before delegating to the original add function. The transform function must be async to integrate with FastMCP's pipeline, even if validation logic is synchronous. Parameter names match between wrapper and original here, but real-world usage often requires transform args with ArgTransform for renaming or hiding parameters. For example, you could map XA and YB while keeping the original function signature unchanged. The forward function preserves this mapping, while forward draw bypasses it entirely for direct argument passing.
MCP, add tool, new tool.
This registers the validated version of the add tool with FastMCP, replacing the original while maintaining the same interface. The ensure_positive transform function performs synchronous validation, but must be declared async to integrate with FastMCP's async pipeline. Parameter names match exactly between wrapper and original here, so forward automatically maps them without needing transform args. For parameter renaming, you'd use ArgTransform in tool from tool, or forward draw to bypass mapping entirely when working with raw dictionaries. The transform function receives arguments after any ArgTransform renaming, which affects how you handle quargs for partial validation. Tool transformation pattern. FastMCP's transform FN creates an async validation layer that intercepts calls before they reach the original tool, with forward, maintaining precise parameter mapping and forward draw, bypassing all argument transformation. Parameter names between wrapper and original only match when transform args isn't specified, as the official docs demonstrate X right arrow A and Y right arrow be renaming via ArgTransform configurations.
The validation layer that stands between client and function becomes both the strictest gatekeeper and the most flexible translator.